And 3, 2, 1. We are live with
Wait,
the
already?
Testcontainers live episode. Uh, might not be. It might be that I need to click the start go live button in
It says
the
live. I see a live. I see it live right there in the corner.
our live.
It says live.
Yes, we are live. Oh my god. Yes, very good. I can see us on YouTube. So let's do it again. We're gonna fix it in post. The sound works. The video quality is decent. Hello, everyone. It is 2023. It is February 2nd. It is the Groundhog Day. We are here with the Testcontainers live episode, and you are watching us. My name is Alexa Life. I work at Atomic Jar, and my guest here is the one and only DaShaun Carter, the husband, the father of 4, which is quite a bit of children, the volunteer, a struggling athlete, and of course, a Spring developer advocate at the VMware Tanzu team. And DaShaun tries to practice to build and run and build better software faster, more efficiently, and all this great stuff. DaShaun, hi, how are you doing today?
I'm wonderful. I've been looking forward to this for a long time. I'm very
Um,
excited about it.
Oh, thank you very much. Yes, today we have a collection of, it's not on purpose, but the topic of today's discussion is like a marvelous collection of buzzwords that you would think this is just for the clickbait. We're going to talk about Spring Boot 3. We're going to talk about the AOT compilation. We're going to talk about GraalVM. We're going to talk about native images. We're going to talk about Docker containers and Buildpacks. How all these come together. We're going to talk a little bit about Testcontainers. I appreciate your fashion choice there. I'm wearing
Yes.
the corporate T-shirt, but you're rocking the open source Testcontainers swag. Great to see that. And it's all those great things. How to build Spring applications. How some people can build Spring applications in this modern times. What are the best practices? How to test those applications, and everything in between. Thank you, everyone,
Indeed.
for joining. If you have social media access, please share the session, invite your friends, colleagues, and everyone. I think it's going to be an exciting episode. And let's get started. Hey, Alina, we have celebrities in the chat.
Wow.
So if you have any questions, please drop messages in the chat. We will try to answer as many as possible, and we'll see how it goes.
Yeah. So say hello. If you're in the chat, say hello. Let us know where you're from. I always get excited to see where everybody's from.
Where are you joining from today?
I am in Minneapolis, Minnesota. Not my home. I'm based out of Kansas City, but I'm in Minneapolis, Minnesota today.
Right. I'm joining from Tartu, Estonia, in the middle of nowhere, which is great. The opposite side of the world. Right. So before we start, tell me maybe a little bit about your interest currently. What are you doing at VMware? What are the interests? What areas you're working on? I know that a few things are happening right now. There is a Spring Essentials Web conference going on, which I would encourage everyone to register and catch the sessions. They're not right
Free.
now live. I think they were early in the morning in US times, like America's time zones. But you can probably get the recordings and get some information from there. What else do you do?
Yeah. So Spring One Essentials was kind of a online webinar, free to register. We had lots of great announcements. That's happening. Also, we have the Golden Path to Spring One. So our next Spring One is coming up in August, I believe. And we're doing these weekly sessions with content every week. I think it's Tuesday and Thursday. We have one coming up later today. And that's really the key right now. That's my focus. Spring One.
Spring
Hello, Brazil.
One.
Hello, Morocco. Exciting.
Hello, Morocco. Aleix, if I'm not mistaken, Aleix is from Barcelona. So we have audience worldwide. Right. Let's get into the topics. Without further ado, tell us a little bit about Spring Boot 3. It was
Yeah.
released in December, maybe November, but like last year, but very close to the end of the year. What are the exciting things in Spring Boot 3?
There's tons of exciting things, but I've got a favorite. My favorite feature of Spring Boot 3 is the native AOT processing that's included. So I'll back up a little bit of backstory. I was I had kind of the data center in the house, VMs all over the place. My data center was running at 1.5 kilowatt hours at idle, and I was like, hey, well, maybe we'll back off a little bit. And I started replacing these big heavy servers with Raspberry Pis. So I have this big collection of Raspberry Pis, and Raspberry Pis are ARM64. Right around that same time, the Spring team started working on or releasing Spring Native. This ability to use GraalVM to do native compilation and generate build packs, generate Docker images. And I got really excited about that. And right away I started, I remember calling up on one of the shows. Everything was virtual at the time. We were still doing the pandemic. And I remember calling up saying, what would it take to do this for Raspberry Pi? And I got a little bit of clues, and I kludged some things together. I took some bash and some duct tape, and I made it work. And I was really excited about having this Hello World Spring Boot app running on a $15 Raspberry Pi. And that was just exciting. So I was like, hey, this is great. Then, a little bit of time passed, and I'm starting to hear these rumors about what's happening in Spring Framework 6 and Spring Boot 3, and how everything that's done on Spring Native is going to kind of come in and be first class. And that got me really excited. And that really is what pulled me back in. The idea that I can use Spring Boot, I can use Spring Framework, and that's the framework that I get excited about. And I could do it, deliver things on Raspberry Pis. And the Raspberry Pis are really just a metaphor for anything on the edge. But it was a different architecture. So it was just that one extra step that made it really interesting to me that I had now. My data center is 92 Raspberry Pis instead of the Dell R710s and the Intel NUCs that existed before. And that's really the thing that pulled me forward. So this is the thing that gets me the most excited, is I can take my Spring Boot apps, I can compile them to a native statically linked binary, and I can run them on a Raspberry Pi. That's really the exciting thing. Even though the ARM64 thing is not a supported path just yet, it's still the path that I'm going forward on, and I get really excited about.
Yeah. But like ARM like architecture is not just the Raspberry Pis, right? Like there are practical applications. You can run cloud machines on like all modern cloud providers that will give you the ARM machines, right?
Yeah, and what does that mean? Like the native compilation, it really means that we can we're replacing the JVM. We're doing this ahead of time compilation. We're replacing the JVM, but we're getting a smaller footprint. We're getting an optimized binary to run these applications, and that it runs on an ARM64. Yeah, that's one thing. Java's always been able to run on ARM64, but I'm doing it on these much smaller computers that have 512 megabytes of memory, for example. Right, something that you can't really take the JVM to a lot of places with only 512 megabytes of memory. So it opens the door, but there's still tons of other options. And in some clouds, the idea of running on x86 versus ARM64, the ARM64 infrastructure is less expensive, right? It's, in some places 33% less expensive to run that same, 4-core, 24 gig box on x86 is 33% cheaper, 4-core, 24 gigs of memory on ARM64. Not every workload is going to behave the same, but some of them are, and some of them are going to behave better. And just to save that 33% off the top is amazing. Now you combine the native image processing, that smaller footprint, not just of what it's running in memory, but also like startup time for serverless workloads. And there's lots of savings to be had. I sat with a customer yesterday and just kind of gave them that little hello world example, and just to see the wheels spinning, like, hey, we've got lots of large organizations that have tens of thousands of applications running in the cloud, and some are over provisioned, underutilized, but there's a bucket for a lot of these organizations where, hey, if we would just convert that to a native image, we'd see savings. The big question, and this is where we come in, the big question is their concern over, is that native image really going to perform the same way that my image performs on the JVM? And this is where we're trying to help, right? I guess I've been saying that if you've got testing in place, the more mature your testing is today, the easier it's going to be for you to move towards that native image running in production, because those tests are going to help you. And the concern is like, hey, how do I validate that my application that runs today on the JVM is going to run the same way? It's going to perform, and it's not going to. I'm not going to run into some edge case when I convert it to a native image.
Right.
And that's where our paths merge. So
Yes. Yes.
having that pattern in place.
No. This concentration and focus on testing and verifying the actual like behavior of the systems is the music to my ears. I think native compilation aside, I think we as the community could benefit from having more robust test suites, and not just in terms of having a reliable way to determine whether something will work or not, but also to efficiently build the continuous integration, continuous deployment pipelines, not to have this bottleneck of like human interaction, not to have this bottleneck of needing to deploy all the work into staging environments to then just wait like a few weeks for somebody to approve it, but like to continuously deliver value to production. Where and like for that process, testing is as necessary as for verification of behavior. Nice, nice. So how do I start? Do you have a little demo, or what are the basic steps? Imagine, no, I of course would some people would consider me an expert in both native image technologies and maybe even Spring, but imagine I'm like absolutely not. What are the steps?
I want to say one thing, and I mentioned this earlier when we talked last week. There is what I feel is that a lot of organizations, going out and at the conferences, I hear and I see a lot more conversations around testing in general. I've had my eyes open to a lot of frameworks and patterns around testing just this year, just in 2023, which we're just getting started. And that part is really exciting to me. What you just mentioned, the idea that we're we're finally getting to this place where more and more people, more and more organizations are doing this advanced, mature levels of testing, taking people out of the path to production and inserting more automation. And that's really exciting to me. It's not just, for the small apps. There is some places where we're going to have to integrate and do big things, but I see it more and more, including yesterday, that people are being pulled out of that path to production and more automation is being put in. So that's exciting.
That is very, very exciting. Um, right. So teach me,
Let's
how do you like, uh, imagine I have a Spring Boot applications, right?
I happen
What?
to have a Spring Boot application. I
Okay.
have one. And yeah, there's some things where, like, hey, maybe I have a Spring Boot application that is serverless, or there are a bunch of them, and I want to figure some things out. I'm looking for savings. I'm looking for performance improvement. There's lots of options. Um, and this whole Spring Boot native, this AOT processing has kind of been added on. What does that mean? What does that mean? It just means that we're going to make a trade-off. And again, the better your testing posture is, the better your experience is going to be. Is it possible for somebody to go in and run this test against all of their applications? Yes, it is. So the idea is that if you have time, we can go in and we can make a simple change. We can spend a couple of minutes to see, hey, is this going to work for us? So what I've got here is, let me make sure I've got the right one. I'm actually going to share a different one. No, this is a good typical example. Hold on. Let's talk about test containers. And this is a simple Spring Boot app. One of the things that we're doing, and this is where I'm at today, is I've got an application. It's doing some really simple things. It's CRUD for a Redis app. Simple. I've got an event controller and I've got some endpoints.
Right. So this is like a sort of a basic application that I would get if I would go to start.spring.io, select the modern versions, Spring Boot 3, add a bunch of dependencies, that I need, and then populate the business logic with the event controller to react to the queries and send and get the events from Redis, right?
Yeah, it's simple. Like I think a lot of people are starting with Redis. A lot of people are starting with test containers, and I think it's a great place to start. From start.spring.io, this is an example of what my POM is going to look like. I've added test containers, actuator, of course. We always want that actuator. I'm using Redis, and it's pretty straightforward. A good friend of mine recommended I try out Rest Assured so I can kind of simplify things going forward. So I threw Rest Assured in here, and we're doing a little bit of validation, and that's it. It's pretty straightforward as far as the POM goes. I did add the native image plugin, and I'm doing ASCII Doctor. I like to do rest docs. This is a pattern that I'm doing with Mario Gray on another show that we do on Tanzu TV, and we've just kind of been taking this test story as far as we can. So we're doing some interesting things over there. On the testing side, though, let me hop over here. On the testing side, I'm using test containers. The idea is I don't want to have things running locally. As long as I've got Docker, I can run these tests. So on the testing side, I'm pulling in REST docs, and I've got a test container. So this is how I set up my Redis image. And all that's doing is saying, hey, when I run my tests, I'd like to run it against a real Redis. So test containers allows me to pull down that latest Redis stack version, and I grab the host and the port. And that allows me to run these tests not against a mock, but against the actual data source, the actual database. I've added some things in here so I can populate my documentation, and I get documentation that I can use, and it's going to be delivered with my application. So this is an example of how I'm using test containers, and a traditional example of how I've used test containers in the past is just kind of bringing that test container, applying my tests or running my tests against that container, that backend.
Right. So like just to reformulate, the test containers will create an ephemeral environment that is necessary for your application to run in. And that is great for a test because you can dynamically configure everything, and you don't depend on the particular static environment to run the tests in, and you can run them locally or in CI or anywhere where there's a Docker environment available, and they will run against the real dependencies. In this case, Redis, but of course you can do anything and all the technologies that run in Docker, which is virtually all technologies.
Yeah, so we're going to try something out here. I'm going to try to do my clean install. And now the interesting thing is here is I'm actually using Test Container Cloud for my backend. So I haven't ran this. We're going to try it. We're going to do it live. It's a demo. What could possibly go wrong?
While it builds, since you mentioned that I didn't script this. If you are watching, Test Containers Cloud is, of course, is the on-demand software as a service platform for running tests, for running containers during your Test Containers tests. You can go. It's currently in the public beta. We recently announced, literally, I think last week or maybe 10 days ago. So you can go to testcontainers.cloud and register and get access. And if you have Test Containers tests, I urge you to explore it, to try it, and I would be welcoming all and any feedback. Right. While I was saying that, I can see the tests were running and the tests pass, which is always a great sign.
Yeah, that is a great sign. And I'm looking at my other. That's good. So we're good. I'm hopping through, and I'm looking. Did it? I'm not sure that used the Test Container Cloud, so that's good. We're still good. But yeah, that's how I do it. That's how I'm normally running test containers.
Right. And in this scenario, just let me understand. Right, your application runs normally on your machine as the normal Java process, so you can debug it if you want. You can set breakpoints. You can change it by just changing a single class. You don't need to repackage anything. You can just run it from your IDE. Boom, it's done. and only the containers are running in the Docker environment. So in this case, the Redis is there, which kind of works very well because you don't want to run Redis and other technologies like that locally, but you also not necessarily want to package your application in there. Cool, good.
That's right.
Good. I
That's right.
haven't seen REST docs in action before. Have to admit, but I'm very excited to learn about that as well.
Oh yeah. So the idea with REST docs, Spring REST docs, is as I'm running my tests. Let's go ahead and look at this. Uh, as I'm running my tests, I want to generate my code, or I want to generate my documentation. So I've given it a documentation spec, and I said, hey, here's an example event that I'm going to pass in, but I also want it to do this this documentation. It's going to generate a snippet for me. So I've identified up here that I want just to make the method name. So let's take a look at what's happening. For each of these tests, I've got these generated snippets over here. So this one that we did was the create. So I've got a create snippet, and it shows this is how I run my tests. This is an example request here, and here's an example response. And I can throw those snippets into my documentation automatically. So here in my documentation, this is my outline on the left. I said, hey, this is my docs, and I want to show how to create an event. And I grab that snippet and I throw it into my documentation. So in my documentation, where I have the create event, I have that snippet. It gets automatically plugged in. So that when I deliver my documentation along with my code, I validated, like, this is exactly the way that the functionality works. This is exactly the way this API works. It shows, here's an example. Well, the request is down here. Here's an example request, and here's an example response from that backend. And this was done using test containers. So I've got real data, I've got real input and output, and it is included with my documentation. It's included with my application as I deliver it. So my documentation and my application never get out of sync. This is why I really like this pattern of using Spring REST docs to deliver documentation with my application.
That is truly really neat, because I can see the value in documentation like that for sure, right? It documents your endpoints. It provides you with the examples. You can take that and like put into curl or HTTP py, and then run it. That is great.
Yeah.
And you don't have to do anything like that. You don't need to do anything specific for this, right? It's like a part of your normal test pipeline.
A lot of people have these tests in place already. They've got, these rest assured tests or mock MVC tests, and the jump from having those types of tests to having them documented is like 2 lines of code.
Yeah.
Right? It's not a big jump. So if you're interested in adding documentation to your tests and having your tests generate your documentation, I call it TDD. The other TDD is test-driven documentation. This is a great place to go. It's a great place to go. It's really, it's a small jump, and yeah, it's
Lovely.
a good feeling. It's a good vibe.
Lovely. Right. Okay. So now, if I'm interested in the cloud efficiency, in the efficiency and the cloud costs reduction, and I would like to convert this application to a native image, I suppose I need to execute some commands.
Yeah, if I want to run this as a native image locally, it's going to take some time, and this is one of the trade-offs. So instead of doing a Maven clean package, I'm going to use a native profile. Can you see? I hope you can see that typing. I know it's a little small. And I'm going to do a native compilation.
Right.
And that's it. But this is going to take some time. I'm doing a stream. I'm on a 16 gig Apple 2020. And
Oh,
it's
so
going to take a
it's a
little
Mac.
time.
It's a MacBook you're running, right? So
It's a MacBook, Intel MacBook.
You're gonna get a MacBook native image.
Yeah, so that's what we're doing. Yes, the GraalVM is going to do a native statically linked binary, but one of the trade-offs when I deliver for a JVM, right? Java bytecode, that JVM, I can run it anywhere. I can run it on anywhere that I have a JVM. But what this is doing is saying, hey, maybe we don't want that. Maybe we're looking for some optimization. We're looking for a better place. And this native compilation takes a little bit longer. But the result is I don't need that JVM. So if I'm delivering something around the globe, I'm going to have a smaller package to deliver. And that package is going to be optimized, but it's only optimized for this operating system and architecture combination. So today, this is a Darwin operating system, and it's an x86 architecture. So I can't take this and run it on my ARM, my Raspberry Pi. I can't run it on a Linux box. This is optimized for this operating system and this architecture.
Nice.
Yeah.
But it's efficient, but it's a binary, right? So what would be your advice if I would like to run it on actual, like, I assume my production is like Linux servers.
Well, one of the questions that I've had, they're like, well, so what's going to happen? What if I've got some of my team that's running on Linux and some of my team that's running on Mac? And what do we do then? We have to create multiple binaries? Yeah. If you want to get the value out of this, yes, you do. But this process shouldn't be done on the developer's inner loop, right? Developers shouldn't be running this as like, hey, I'm going to run and test and I'm going to wait 5 minutes and do the testing. That shouldn't be a part of the process. And once you can get over that hurdle, that mental hurdle of, hey, this is going to take a while, understand that this is something that you should be putting into your pipelines, your path to production, or your path to dev even, because there's value here before I get to production. I'm a developer advocate, and this is I think a big developer plus is I want to be able to deliver these applications, all the services. Maybe our organization has hundreds of services. Maybe our organization is Netflix. And maybe I want to be able to test these things. Maybe I want to be able to deliver test containers to the rest of my team. I want to be able to deliver these services in a test container so they can have backed services with real applications. Well, if it's a statically linked binary, I can do that. I can have hundreds of those services running on my 16 gig laptop. I could have them scaled to 0. There's lots of value in delivering these statically linked native images to my developers, because it's going to take up less of their resources on their laptop. So there's tons of ways to explore that, and it's a pattern I'm a real big fan of. I like to have those things running. I like to have a Kubernetes running on my laptop. I like to have things scaled to 0 or even not scaled to 0. I can have 20 of these services that are going to be 100 megs a piece. I can still do that on my laptop, and that's exciting, right? It's opened the door for types of development on my laptop that I just didn't have an option for not too long ago.
Yeah. It also brings like the production characteristics of a Java application very close to other like statically compiled languages like Golang and others, which is very, very exciting for the ecosystem in general, I believe.
I'm not going to name names, but recently we've had this conversation. Oh, you can't do serverless with Java. Like, you have to have this kind of app. Oh, it's got to be written in Node, or it's got to be written in Go, or whatever. And we had a little friendly, hey, let's put our money where our mouth is, and let's run these applications. Let's take an open API spec API, and let's both code a CRUD application against Redis. And let's just see how things work. We did 2 things though. There's 2 parts. How long does it take you to write it? How long does it take me to write it? Like, we're going to go side by side, front to front. Like, let's go, and we'll write it. And I won by a second or 2 on how long it took me to write it. But that counts. I didn't have to switch my language in order to get this thing done. And then we went head to head.
Right.
And we ran them.
And the other language was Golang, right? You said.
Yes.
Oh, Node.js.
It was Golang.
Golang? Very good. Yes. Very good. Did that person create any tests?
No, actually, we didn't have tests. This is kind of like a grudge match. Oh. Let's go just to run like the what is the output? How fast does it take to get up, and how fast to go? Like, if you're comfortable.
No, you should have tests. Absolutely.
Yeah, you absolutely have tests.
Maybe in the next installment of your little friendly competition there, yes, what you can do, you can actually create tests for the implementations that you have there. And, well, naturally, you're going to use Testcontainers Java, and the Go variant could use Testcontainers Go. So even your test could be like very matching.
That could be the mark. That's what we should do.
Yeah.
Is we should just make the test the benchmark. That's a
Yeah.
great idea.
No, this is very interesting because I've seen at Devox Belgium, I've seen a very similar a session with a very similar premise from Ishai from the AWS languages team. I think they compared GraalVM native images, an implementation of the application in Java, and an implementation in Rust, which is allegedly even more efficient, like zero cost abstractions and everything. And that was a very, very interesting session. And I'm sure somewhere in the description below, like tomorrow, there will, or after the session, there will appear a link, or maybe somebody in the chat can find that. No, that was cool, and I think it's a very interesting experiment.
So this is running right now, and this is where, as I'm out trying to demo and deliver the value of, hey, here's what we're doing with Spring Boot AOT. And this is exactly what happened. Was I in New York? I think we were in New York. And I was like, man, this is taking a little bit too long. I don't have a whole lot of other stuff running, but I am on stream and I'm doing this live. And it takes a little bit of time. And sometimes it's hard to decide like how long it's going to take. I was planning for 5 minutes and it ended up taking like 13 minutes in this one example. And at that point, I was, sweating, doing the dance. Hey, it's a demo. What else could possibly go wrong? And right after the session, Sergey happened to be there, and we had a little chat, and we got to like circle up, and we're like, hey, let's see if we can figure out another way. And we use Testcontainers Cloud. So after this one's done, we'll jump over to that, and we'll see what we came up with because it's really exciting, especially for me doing this on the road. Again, right now, this is using my laptop. I don't know if you can hear my laptop fan. I'm warming up my hands. It's really, really cold here in Minneapolis right now. So my computer's putting off a little heat. The fans are going, and it's working. So I'm not going to be too upset about it.
Right. It is definitely a process. I know that there were very many improvements in the recent GraalVM releases towards the efficiency of the native image compilation. And big kudos to the team. I think I've seen incredible, and well, my past experience includes working with the GraalVM team for a number of years. So I was sort of there from like the beginning of the public life of the GraalVM project, and I've seen how much it took time back then to compile a native image. I think my first Spring application that I compiled, it was my MacBook. It wasn't the best. It wasn't the most powerful. The CPU wasn't the fastest. It also ate all the memory that I had. It wanted to swap. It took more than an hour, and my laptop was completely unusable. So now the recent examples that I've seen a Hello World application compile in like 13 seconds, which is, I was super surprised. But like 13 seconds is not even the time that you actually need to think about like, oh, is it gonna slow me down? You're not playing like a first-person shooter game. You can take a break for 20 seconds to get this binary, for example, to run your tests locally. And of course, for a larger application, it might not be like 13 seconds, but it is definitely not in the ballpark of like dozens of millions. Well, it depends, but there are great efficiency improvements there. Right.
Yeah. My first native builds were literally on ARM64. And on a Raspberry Pi 4, 8 gigs, it was taking 30 minutes to compile Hello World. So this is nothing compared to how much I had to wait. And it didn't feel like that was too long ago. But one of the things that I'm having problems with, one of the big questions that comes up with customers and audiences is, hey, we're trying to move from Spring Boot 2 to Spring Boot 3. What do we do? We're still stuck on Java 8. What do we do? The first thing, if you're trying to go to Spring Boot 3 or Spring Framework 6, you need to understand that we've rebased to Java 17. So in order to use Spring Framework 6 and Spring Boot 3, you've got to rebase it. You've got to use Java 17. So one of those exercises that I recommend is do the JVM move first. So with your Spring Boot 2 apps or your Spring Boot 1 apps, do the JVM move first. You're going to find out that there's just a ton of performance just by upgrading the JVM because the JVM has made so many improvements. And you can actually do some experiments. Everybody's like, well, which JVM should I use? What I like the Graal version of their JVM because I've got enough repositories, or I've got few enough repositories. I can run this test with multiple JVMs across all of my demos that I'm going to go and share. And I can do that analysis for myself, and you should too. Find out which JVM is going to give the most benefit to your workloads. And I highly recommend you do that move first. And I'm just saying I'm a fan of the Graal JVM. Then
Excellent.
once you've done that, then you've got the base, you've upgraded, you've gotten a lot of performance improvements from your JVM, and somebody's going to get a pat on the back for that. Somebody's going to say, hey, how come our stuff is performing so much faster? All we did was upgrade from Java 8 to Java 17. That's why. And somebody's going to get a high five for that for sure. I saw my screen just flash. Sorry about that. But then that's the first step. Then you can do the migration of the rest of your app and you can validate.
Yeah. No, definitely. And Java 17 is currently the current, I think, LTS version,
Yep.
which is the, I don't even remember what that stands for. Different vendors.
Long-term support.
I think different vendors abbreviate that differently.
Yeah. But Java 19 is right around the corner, right? Java 19 is coming next month.
With Java 20.
Java 20. Java 20 is coming next month. Yeah. So this is it's moving fast. So
yeah, we have now virtual threads, right? It's a preview feature in 19s.
Yep.
And we have a number of other improvements. Do you have a favorite, like, new Java 19, Java 20 feature? Or
I have a really interesting use case where somebody was using Spring Boot, and they had this process that was taking a while to boot up. And they were looking at it, and they had pain because on startup, their JVM was eating a lot of memory. The JVM is climbing up to 20 gigs. So they had to create a container size of 20 gigs. But after that initial cache load or whatever, then the JVM came down and was running at around 2 gigs. So they were like, this is a concern. They weren't concerned about the 27 minutes that it took. They were thinking that maybe there was a way to go faster, that maybe we should use virtual threads. And I said, before you do that, how about we try it with native images, do the AOT processing. So we do a little bit an experiment and we run it, and voila, it actually takes longer to run, so it took, let's say, 35 minutes to run, but the container image didn't take 20 gigs. They didn't have to deliver a 20 gig container image to their infrastructure. It was only half a gig.
Oh, so that's not bad.
Well, think about this. Even though it only took, it took longer to run, so 27 to 35, let's say, whatever the number was, but that image that we're deploying, and if we're deploying 100 of those images, 20 gig images versus a half gig image, who cares about that extra 10 minutes?
Yeah.
Because
it's all
the
about
amount that they're saving in real money is a big difference.
Yes, absolutely. So, network is not cheap, and it's not just network, right? Because like a smaller image will deploy faster, it will unpack faster, it will take less space in your like artifact repositories and whatnot.
On your Kubernetes cluster, right? We don't have to provision as much memory. So that's a big real dollar savings that they're getting, right? And sometimes you don't look at those metrics like, oh, hey, it took longer. I bet you there's a bunch of workloads that even if we slowed them down a little bit, we could save a lot of money.
Right.
Like it's just it's 2023 and we've just got a lot more things that we have to take into consideration because all of this other work that's been done for us, we need to take advantage of it. Well, look at that. It only took 13 minutes.
You were spot on that 30 minutes build.
But now I've got that static linked binary, and we didn't even run the first one. But now, hey, this runs, and it's been tested. We'll allow
how do you run it? Do you have Redis somewhere installed?
Actually, I didn't install Redis, and that's what I should have done. I should just have it so I don't have Redis running. I'm just going to show that this is up, and it didn't take a whole lot to run, and I'm going to show that this image doesn't take a whole lot of memory either. So it's that Spring Boot app is running in 63 megabytes of memory.
Yeah, yeah.
So that's pretty exciting.
That is very good because I can package it in a very small container, right? I
Yep.
can give it like maybe half a gig of memory. I can give it like maybe one CPU, and it will run and feel very, very comfortable in those nicely packed containers. And my DevOps, my operations people, and me myself, if I'm running a DevOps team, I'll be very excited for being able to run my Java applications the same way I run other applications in other languages, right? I don't need to provision everything. Like, and this is like a very big point. I think that was recently I've talked to someone and they were trying to simplify various deployments, right? Both the production and not just to have they're like CI pipelines deployments, not just to have like consumption performance improvements, but also to have consistency across how they run different applications. Like you don't want to give your Node and Go applications those small containers, and for the JVM applications have like a separate config that gives them like 2 CPU, 3 CPU, and then like 8 gigs of RAM or 4 gigs of RAM. You want everything to be the same, right? Because if everything is the same, treat them as a cattle. I'm not sure if that is like still how we phrase that.
Yep.
But the containers come and go, the pods in the Kubernetes come and go, but like you get the unified experience, and the same sort of like in CI pipelines and everything. I remember now where I heard that. It was about the enabling Testcontainers Cloud instead of having different deployments for like CI workers that run tests without test containers, and then the tests that run with test containers. So because like you might need or not need like a bigger machine to run Docker. Right, your screen disappeared.
Yeah, I took my screen off. I was trying to pull up another test where I am connected to Test Container Cloud, and I'll tell the story while I try to fix this other one. In New York, again, 13 minutes of a runtime. Got to sit next to Sergey, and all we did was we went through this example of I can actually generate my native image by offloading it to Test Container Cloud. And for me, for the demo, for a time like right now, that would have been super powerful, and it has been ever since. But the idea is it wasn't really just that use case. The use case has been expanded, and now it's the use case, it's the pattern that I'm using with the rest of the community. So even though this isn't going to work, we're going to jump over to it anyways, and maybe I'll figure it out as we go. But this idea that I want to have that confidence that that native image that I've created is going to work in production. That's the question. That's a question that everybody is trying to, answer. And well, you got to have tests first, right? You definitely have to have tests first. And so start there, and then we can talk. And once you've got those tests, then you want to validate your native image the same way that you're validating running your unit tests. And that makes sense. So the pattern here is that, and this is the work. I'm going to close that because I'm not sure what's happening. And I don't want to get flustered. But the idea here is I've got this pattern of I want to run my native tests or one of my regular tests the same way that I normally do. So I'm going to jump into my test suite here. And I haven't done a whole lot. But I've got a test. I just want to make sure that I've got an actuator health endpoint. And that works. That's great.
So this is a normal Spring Boot test. It will spin your application. It's a web test client test, so you will bind it to the server running the Spring app, and you will hit the local host port actuator health endpoint and ensure that it returns the body that is not empty and maybe 200, right?
Yep.
Good. I'm on board.
So that makes sense. Yeah, and out of the board, something that we can code during a demo. right? That makes sense.
Right.
But I don't want to do that inner loop. I don't want to create the native image during my inner loop. I want to make sure that I'm doing that at the right point in my path to production. And I jumped in, and what I found was I liked the way that Gradle was separating this out for me. Gradle had this approach where I could say, hey, I want to just do my integration tests. So somewhere here, I said, hey, boot build
Right.
image, where's my integration
Integration
tests?
test.
Yep. So I have this integration test sources over here, and this is where I want to do that test. So on my path to production, I want to do my inner loop testing. Great, it's going to be nice and fast. But after that, I want to validate that native image. And here's what I can do. So I put it into an integration test, one that's not going to be ran all the time. And I'm doing this this pattern where, hey, go ahead and I want to create, this is creating a future. I want to create that native image. So this is the section that I now have made into like a Spring shell. So I can just simply add this to my classes. It'd be nice to add that maybe to the initializer. But the idea is that during integration tests, I want to run this as a part of the image. I'm pulling that package down. I want to run the boot build image and give it an image name. And then I want to run a test against it. I want to ask for that application, and I want to hit that endpoint.
Right. So your preparation code on the top. So the test is very much the same, I think. So this
the test looks
future
very
code,
similar. Actuator health, make sure it's 200. Yes, that'd be great.
right. So, and this preparatory code that is in the resolve method, what it does, it runs Gradle, and it runs Gradle command with the boot build image, and it tags that image. So boot build image will build me a Docker image.
Yes.
With my application.
Yep.
And that would be my native image binary packaged in the Docker container.
Yes.
Right?
What that output, yes, is going to be that native image. So that's that native image that I then get to go and run. So that's what's returning. You remember I set that future. What I'm getting back from that image future is that native image that I can run my tests against.
Right. And you package it in a generic container. So your the test containers will spin it up for you. It will probably take just a fraction of a second because it's a native image. So you can do that for every test if you prefer, which is kind of cool. And then you do the configuration, and then you run the same test, and you just not hit the local Java process that you're running, but you're actually going to that generic container running somewhere.
Yes.
That is pretty.
It's pretty advanced, and right now, at least it's the way that I'm pushing forward. I got really excited about Gradle, the way that I could integrate and do that integration test. I've come to learn that I can do the same thing with Maven. Maven has an integration test phase. The thing that I've adjusted is with Maven, it has a schema. So I can assume a lot more things about the Maven's pom.xml than I can about the build.gradle. Gradle's amazing, but I can't automatically go into a bunch of Gradle projects and insert things and make modifications without knowing how that Gradle, that build.gradle is set up. So it's great, but for me and what I'm doing, I want to have that automation where I can go in, I want to be able to add this test container and add these integration tests and be able to automate this native image integration test to existing projects. So that's where I'm going down. And the question that I had for you last week was, hey, we want to be able to take those same core tests that I have, that I'm using my unit tests, and I want to be able to use those exact same tests with this native image on top. So instead of hitting the rest assured implementation, I want to hit that native image using the test container. And then there's another question of, what if I want that test container to be backed by a test container? I think I have that solved, but it's not working at the moment.
Right. Okay. I think I understand.
There's questions here.
There are. It's a mix of very exciting different technologies.
Yes.
And if you are building libraries, I know that the native image team has created the way to package your unit tests into the native binary, right? The native image, and run your unit tests that way. And I think it works for the libraries very, very well. But I believe that approach falls a little bit short for the actual applications, where indeed maybe the integration tests, like the actually higher level functional tests that use your application, will provide you with more reliability and just confidence, right? Like
Yeah.
you want to be confident that your test suite executes things in the environment and with the dependencies that are going to be used in production. And that was a very, very neat use of test containers, because you can have a larger setup as well, right? Like if your application require like a database or Redis, as you showed,
Yep.
you can have another container with Redis running, and you can spin it up using test containers as well.
Yep.
So your whole environment could become reusable, not just between the local machines and CI, but also between your kind of inner development Java process running tests and your test against the native image.
Yeah. So right now, I don't have a good example to share of where I'm trying to get to, but let me just kind of explain. I still want to have all of the same tests. I want to validate that I've got the exact same tests that are running against this native image that I'm going to send to production. So what I'm doing today, and this is probably where everybody could start, is like I'm just literally copying those tests over that are going to run against that native image that I've generated with my with test containers. So I'm generating the native image, and then I'm running the exact same tests. I'm also copying over that test container, and I'm starting that Redis test container the same. So in a separate test, again, there's a lot of copy and paste today. What I'd like to have is that pattern. So I'm going to ask, I'd like to have that pattern where I want to have a test that runs with a Redis test container in the back for my unit tests. And then I want to have that same suite of tests running with that same Redis test container backed against my native image test. That's where I'm trying to get to. That's where I was hoping to
Yeah.
get to today.
Yeah.
But that's where I'm trying to get to, because that's the key. And then have that automation that says, hey, you've already got those tests. Let me help you. Let me just insert that test so that we can go to production against a native image with the exact same tests.
Right. Right. No, I think that would be great. I think that would be my like an approach that I would recommend myself. Right. You really want the set of tests to act as the sort of the contract for what the application has to be doing, right? And I think it also helps very much. I'm not sure. I think like so. Spring Boot 3 has the native image support, ahead of time compilation support built in. But it also, in the past, if you add your own libraries or something, there's still the GraalVM agent that you are ought to run to generate the config for the dynamic parts of the language. And also, like you could use your tests to exercise all the code paths to generate that. So
Yes.
you will use your test 3 times, right? You will run them to generate the config. You will run them to verify that your inner loop current development is what you expect it to be. And then you will also verify using the same test suite that your native image behaves as it should, sort of feeding 3 birds with a single test suite.
So let's double click on that, because that's the next step, right? Once we've gotten the community to say, hey, yeah, here's how you run the natives. Now they're taking it forward, and they're digging in. Oh, and they find something that's using some library that it's not working out of the box. That step, you just brought it up. We brought it up earlier. Of the more advanced your tests are, the better your path to those native images in production is going to be. So you brought up adding that agent. So when you run your tests, we can identify where that code is being executed, where that code is going, and we can provide those hints to the GraalVM, so that when we do the ahead of time processing, that we have the hints that we need in order to generate that image. That is a huge step, and that's kind of the next step. Once you figure it out, hey, this is maybe something I want to pursue. understanding that process of how to take an application that might not have all the hints provided already, how to generate those hints in order to build your native image.
Nice. Do I need to be worried about the library support? How is the current situation with the library support in native image?
So here's one of the interesting things. What the Spring Boot team did was the way that they are delivering their libraries, the way that they're providing hints to their libraries, they've made it really open. So the Spring team made that open so that anybody that's delivering libraries that wants to add this native support, they can go in and see how the Spring team did it, and they can provide them the exact same way. Also, the GraalVM team. Now there's this ecosystem of, hey, we want our libraries to be supported, and now there's a repository. I don't know if you've got the link to that. I don't have it handy on this computer. But there's this repository of here's all the libraries that are now providing support for GraalVM and sending it out to the public. So this is a movement. Anybody that's providing libraries that would like to be, on the train and catch and do what all the cool kids are doing, this is what we're doing. We're starting to provide those hints and making it public, make it known. And if you want help, like this would be the time to raise your hand. So if you've got a library and you'd like to support these GraalVM native images, and maybe you'd like some help, now's the time. Raise your hand. Let us know, because we'd be happy to help.
Yes, I assume the Spring team has quite a bit of expertise in how the native image compilation works, because it's been a journey.
I'm going to say this. This phrase has been coming up a lot lately, and this concept has been coming up a lot lately. I was a Spring developer advocate a long time before I worked for Spring. There are a lot of Spring developer advocates out there. Just because they don't work on the same team, they don't work for Tasha, that doesn't mean they're not a Spring developer advocate. I would like to say I'm a Testcontainers developer advocate as well. Just because I don't work for the team, I am out here, I'm preaching, I'm doing the things like helping people understand that there's a better way and follow us. Like, let me show you. And that there's a community around this. So yeah, around the GraalVM, around Testcontainers, raise your hands. Like, ask the questions. That's one of the best things about being a part of this community, about this extended community, is that it's full of great people that are willing to help.
Yes, I love that very, very much about the ecosystem and the community. What's it sounds silly because we are talking about Spring. So what's the best way to connect with the Spring community? With you have like a Slack workspace or something?
Well, we have
Are you too big for that?
A really cool thing that I do with Dan Vega, another Spring developer advocate. We have Spring office hours, springofficehours.io. We'll get you to our shows where every week we have a live stream just like this, and we're answering questions from the community. We'll always have a demo just like this. Like, the idea is we want to connect. But we're active on Stack Overflow. We're active on the Twitters. There's a Spring community, developer community on Twitter. There's a Spring user community on LinkedIn, and we're at all the places. If you want to get a hold of me or Dan Vega, hashtag Spring office hours, and one of us will magically show up. Don't say it 5 times in the dark. Hashtag Spring office hours will show up.
Yeah, I got it on screen here as well.
Yeah.
This is a great tip. There were a bunch of episodes from the past, and I'm sure you can find answers to all your questions, and just go hang out, watch it on Twitch. I know that if you're interested in the GraalVM, there is a community Slack that you can find by
Where is that?
to graalvm.org, and then I think there is a link to that. Let me just quickly. Community. Stay connected. You can just go to the Slack channel there on the web page, and if we are talking about Testcontainers, you can go to testcontainers.org, getting help, and join our Slack workspace as well, where there is a community of like-minded individuals, and we can help. Both the team and the community members can help you resolve your misunderstandings, help you with the tips and tricks for the particular setups, how to resolve the problems with various CI pipelines, configurations, and all that. Join us. We'd be happy to hang out together, and I'm sure all those projects will be very, very welcoming and nice.
Yes.
Right, we are at the hour, so I think it's time for a few closing words. Thank you very much, DaShaun. This was excellent. I think it was very, very exciting. I think we went through more stories that I originally envisioned, but I enjoyed this immensely. We've talked about Spring Boot 3 and how it has support, built-in support for the native compilation, native support for the native compilation, and AOT. We've talked about GraalVM. We've built the native image. We looked at the tests, how you can test your Spring Boot application with the high-level functional tests using test containers, and rest assured, you showed me a very, very cool example how Spring docs,
Spring REST docs.
Spring REST docs can generate that documentation from my tests, which is an incredible neat thing. And then we looked at how you can even run the same test suite theoretically against the application compiled as a native image running in a Docker container with test containers. So I think that was quite a bit of content. Anyone who is listening, thank you very much. And if you have any further questions to DaShaun, you can find him on most socials. I think he goes by at DaShaun.
Yep.
And then go check out the Spring Office Hours or the Spring Essentials Conference. And I don't know, subscribe to this channel. We are having more those Test Containers Live episodes.
I think you're going to be joining us, right, on our golden path to Spring 1.
I will.
I think you're going to be joining us real soon. I don't know the date off the top of my head, but yeah, come back for that too. I think what I would like to do is I'd like to maybe sync up with you before then and come back and revisit this and have all the things working together when I don't have a Podman instance running in the background that messed up my demo. I'd like to circle back and I'd like to run this demo with you and let's show how we're doing. Take our tests and extend those tests to this native image test using test containers to validate our integration tests on the path to production.
Right, absolutely. I think that session will be on March 9th, if I'm not mistaken, but you can check that out in the links somewhere. And yeah, the conference-driven development is real. Now you're challenging me to have this demos ready. I accept. Yes. We'll see how it works.
All right.
And I will be in the Slacks for all those projects, and I will be asking questions. So for everyone else, I urge you to do the same. Learn, stay curious, and yeah, thank you for coming.
This is wonderful. Thank you.